Okay, today in class we were going through the prefixes that you'll be needing to know to name things for tomorrow, and we saw that fluorine would go to fluoride, chlorine as an ion would be called chloride, bromine as an ion, see he's got this extra 1 minus, okay? It means he has one extra electron. That makes him an ion, and he's called bromide. Iodine becomes iodide, and astatine becomes astatine. Astatide. Thank you. All right. Now, as we go forward, we had these in the do now, but one of the students asked a good question, so I'd like to approach that before we do the do now. We have this ion that we call carbonate, which is a 2 minus ion. So when we're writing this guy, we of course put carbon in the middle, and we're going to have 3 oxygens on him. And so I'm going to go ahead and run the numbers. Carbon, what's his valence? 4, and there's only one of him. So you get 4. How many for oxygen as a valence? 6 times 3 gives you 18. But when you have an ion, you have to add, if you have a negative ion, which this guy is, or you have to subtract if you get a positive ion. Okay? And that's the only difference between ions and non-ions. The other thing you have to do is put a bracket around it and indicate that charge, and that way we'll know that we're adding 2 electrons. And that'll give us 2 more. So we have 24 in this structure. Okay, now there's no ownership of electrons in the Lewis structure. You just put them out. So let's do it like we always do. And we have, in the Lewis structure right now, we have this guy with how many electrons? How many here? How many here? Okay, so we've already used 6. And we have 18. Now, let's get this over so it doesn't get confusing. And now let's go ahead and put our electrons in. We have 18 to give, right? Yes. Okay, we have 24 because we have the 2 electrons extra. Okay? That's what this is all about. Every polyatomic ion would have that indication that it has extra electrons, or it would be positive if it lost an electron overall. So it's different than how we did the other guys, because we have to account for that difference in the ionic charge of the overall molecule. So let's take our 18 that are left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Bingo, we're done. So for this guy, it's easy. Except that we got a problem with carbon, huh? Okay, we got all our electrons on the playing board, but we don't see carbon with 8. So what are we going to do? Sharing is caring. Of course. How could I not think of that? So let's just take any 2. It doesn't matter. And we're going to make a double bond. So this oxygen still has 2, 4, 6 for one bond, and 8 for the second bond. So he's happy. Carbon has 2, 4, 6, 8. So carbon's happy. This oxygen has 2, 4, 6, 8, and this one has 2, 4, 6, 8. So everything is good. Our total that we should have in there is 24, and then we have to account for these 2 extra electrons. And that's included in the 24. So that's how many need to be in our Lewis structure. Yes? Yes, because we've lost electrons if we go positive. We've gained electrons if we go negative. Either side of neutral. Okay? Gaining electrons mean we have a net negative charge. Yeah. Why did I add the line? Because I wanted to have this oxygen share 2 of his electrons. And the way we do that is with another bond. So now there's 4 electrons bonding this oxygen to this carbon. Make sense? That's all you do with an ion. And there may be one of those on your quiz. Well, I'm going to show you a slightly different method. If you like it and it makes sense to you immediately, use it. If you don't like it, just stick with what you have. But I started doing it and I really liked it. Okay? I'll show you what I do. You all know how to do this. This is carbon tetraiodide. Why is it tetra? That's subscript of the iodine. Okay, this isn't Cl. This is Ci. And there's 4 of them. So we do the normal tetrahedron. And we have the iodines. Whoops. That's right. And I. All right. Now we put our molecule together. Let's give now, you see, this is something that that I've seen a lot of students do. They just put enough electrons on everybody so they have 8. Why not? There's a good reason for that, but we check for the reason later. Our emphasis is that everybody has to have 8. Does our carbon in the center here, where are you? Here you go. Does this carbon have 8? He sure does. How about this guy? How many does he need? 6. Let's do it all the way around. Makes all kinds of sense, right? Everybody has 8. We have a happy group of ions, of atoms. So, we can't leave without checking. Now we do the numbers. So our number here is iodine, how many times? 4. 4 times 8 is? 32. So, 32, that's the number we have to get, right? So, carbon, valence? Valence? 4 times 1 is 4. Valence for iodine? 7 times 4, 28. Total, 32. If you get the same number, your valence structure is good. How do you like that? You see, you're supposed to check on the back end. The reason I like this is because it forces you to check everybody has 8 on the front end. If you like it, use it. How many like it? Oh my straw poll is dismal. Yes? I want each iodine to have 8 electrons. The question was, how do I know how many to put on the iodine? He's got to have 8. Because atoms will not form a molecule without getting an octet. And our exceptions are hydrogen, beryllium, and boron, right? They'll need different numbers. But everybody else, they have to follow the octet rule. Because that's how they get stability. They're more stable this way than as an individual atom. Okay? And we already did the NOON 17, so we know all the diatomic molecules, right? Atoms that form diatomic, don't forget that. NOON 17. Nitrogen, oxygen, fluorine, or fluorine. Okay, diatomics. Nitrogen, oxygen, hydrogen. That's the no. With a really long O, so you know that's an H. The on doesn't mean anything except it helps you remember. 17 is group 17 on the periodic table. Okay? Any other clarifying questions? Okay. On the future ones, would you like me to use the new method or the old? How many want the new? How many want to see more of the new? Maybe one more? Would you all settle for one more? Because I'd like the folks at home to see one more. And then I'll go back to the old method. Okay? So, nitrogen, 3 chlorines. Did everybody get that far when they were doing the do now? Sam, put it away. Is this good so far? Okay. How many electrons does nitrogen need? He needs 2 more, doesn't he? Okay. Now he has 8. And the 8 are counted 2, 4, 6, and 8. Okay? Let's do the chlorines. 1, 2, 3, 4, 5, 6. That gives chlorine 8. And I'm going to do that to all of them. My Lewis structure is now drawn, but I'm not positive it's correct. So, nitrogen, valence. Valence. I times 1. All right, chlorine, valence. Times. Okay. So far, so good, right? Let's count. How many? 8 in the circle. So we have 3 of those for 24. That takes care of the chlorines. And then we have 2 more unshared pairs on the nitrogen that didn't account for. So I have put those in too. Is my Lewis structure good? Absolutely. Okay, so you've seen this method. I want you to notice that on today's whiteboard, and this is already online, I have 3 videos for you to look at. If you're having any trouble with Lewis structures, these guys will do it for you. And if you like the method I've used so far, Science Post will also go through that, and he's going to show you the, Ket's book does my style. Science Post is just dealing with the polar molecule versus polar bond ideas. And this is fabulous for that. What's the difference between? I hope you find this helpful. This last screen, I had to restart because I realized that this last screen is the answers for things that you could test your knowledge on. And I'm giving you all the correct